everyone. Welcome to the TDWI webinar program. I'm Brenda Woodbridge, and I'll be your moderator. For today's program, we're going to talk about empowering legacy renovation using a modern data layer. Our sponsor today is Redis. For our presentations today, we'll first hear from David Loshin with Knowledge Integrity. After David speaks, we have a presentation from Ash Sahu with Redis. But before I turn the time over to our speakers, I'd like to go over a few basics. Today's webinar will be about an hour long. At the end of their presentations, our speakers will host a question and answer period. If at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, click on the Help area located below the slide window and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. And finally, if you'd like a copy of today's presentation, use the Click Here for a PDF line there on the left middle of your console. In addition, we are recording today's event and we'll be emailing you a link to an archived version so you can view the presentation again later if you'd like, or feel free to share it with a colleague. Okay, again, today we're going to talk about empowering legacy renovation using a modern data layer. Our first speaker today is David Loshin. David Loshin, president of Knowledge Integrity, a consulting company focusing on information management solutions for information quality, business intelligence, and metadata management. David is a recognized expert in information management and writes and speaks on the topic frequently, including at TDWI conferences and events. David is also an affiliate analyst with TDWI and the program director for the Master of Information Management program at the University of Maryland. David, I'll turn things over to you now.
Thanks, Brenda, and thank you to TDWI for inviting me to speak about this, and also thanks to the sponsor, Redis, because they have interesting things to kind of fold into this conversation. So here's what we're going to talk about today. Some trends in general in financial services, the pressure in those organizations to modernize, some of the issues that have cropped up with this concept of digital transformation, the use of in-memory databases, and then how we can leverage what we're talking about to evolve towards a modernized environment. So let's start out by talking about the modernization in the financial services world. And I think the way I really want to launch this is to talk about the consumer-facing perspective to financial services businesses and how that has changed, I would say, within my lifetime. This image here that I put up on the screen, this is a picture of what a bank looked like, say, this might be from the 1930s or 1940s, but I actually worked for banks in the 80s and 90s, and I recall actually part of the work that I did involved going into the physical sites and having to get in lines that were literally the same as what you see in this picture here. And you would have a bunch of different types of individual consumers who are, or players in those services who are coming in to do transactions. And in general, customers that would go into a bank branch they wouldn't be doing a single transaction at a time. They would bundle their transactions. They would collect, checks or whatever, withdrawals, all the requests for the transactions. They'd bundle them up for that visit to the branch, and they would when they got up to the window, they would do interactions with an individual on the other side of that counter, the teller, who would take care of manual transaction processing with a paper trail. In fact, some of you may be the same vintage as me, may remember walking into a bank with a little booklet that they would record the transactions with a pen in that booklet, and that was how they managed the customer interaction with those transactions. And literally, there was limited cross interactions among services. So if you had a savings account, you would do all your savings account transactions. You had a checking account; those were separate transactions. If you had multiple accounts, you would be involved in having to bundle up all those transactions. Now, if you look at today, None of those things happen. I mean, I have gone into a bank on occasion, but between COVID and the emergence of mobile apps that are providing me with the capabilities of doing the things that I would have to do in actually going into a bank, I literally, the only reason I go into the bank is half the time is just say hello to the people that I know who I used to see when I used to walk into the bank. Mobile apps provide virtually continuous connectivity between the customer and whatever financial institution. They are straight through automated processing of transactions to the point where I don't even have to go into a bank to deposit a physical check. I can do that all through an app, and it's integrated componentry with the photographs, et cetera. And not only that, it's fully integrated across products and services. So I log into my app from the financial institutions that I work with. I can see everything. I don't have to have a separate application for my savings accounts versus my checking accounts or my money market accounts or business accounts or any of those interactions that I would do. Everything is fully integrated, including credit transactions, et cetera. All of that is all available within a single interface. And so what used to be something that would involve standing in lines and waiting, on occasion and bundling things up so that they would all be processed in a batch, and then consequently the banks and the financial institutions would also bundle up all their transactions and process those in batches. Today, everything is migrating towards immediate transaction processing and immediate results. And so what this is saying is that if you're a financial institution and you are fundamentally built based on a reference architecture that was well established 30 years ago, and those of you who work in bank back offices are probably familiar with a couple of prototypical textbooks that have the full scale back office architecture laid out within the book, so that it's almost like literally when you say a textbook implementation, that literally is what it is. Those banks are now at a position where they are at risk of becoming eclipsed by what we would call a digital first or a digital only or an online bank or a neobank. These are financial institutions that are solely operating online or largely operating online only. Banks or conventional banks need to start shifting towards customer focused digital banking to meet the needs of digital savvy clients. And I'll give an example in a couple of slides of what I mean when I talk about that. And yet what you've got is a fully indoctrinated on-premise data center centric with large investments of high cost hardware sitting within the organization's domain, when that needs to compete with more agile environments, financial institutions that are literally they're emerging as cloud-oriented, cloud-based, online-only institutions. So these legacy systems not only are deeply entrenched, it also creates a hurdle for modernization, because it's very difficult to even consider what the transition from this batch-oriented mainframe only architecture to a non-batch straight through streamlined architecture that leverages available high performance computing that you can get in the cloud. So here are some of the issues that exist within legacy financial services systems. For example, reliance on a legacy mainframe platform, batch processing, and limited amount of streaming. Again, my experience was 30 years ago. I worked for an investment bank. At the time, the things that they were talking about migrating to were things like straight-through processing. I literally 6 months ago, I was working on a project with not a financial institution, but one that involves financial transactions, and they still are reliant on data center mainframes for doing their batch processing, and they are dreaming about concepts of straight-through processing or streaming processing. Their systems that are huge investment in capital acquisitions are sized based on what an expectation is of the maximum demand for processing power is going to be, and they build their systems based on those presumptions. If things happen in the industry or out in the real world that require scalability or increased performance, there's no immediate adaptability of those mainframe systems. They have to go out and acquire additional hardware to physically scale their system architecture, as opposed to the way that more agile organizations are able to dynamically scale when they're relying on, say a cloud-based architecture. The focus is largely on transaction processing. A lot of that is actually driven by requirements for reporting to make sure that compliance is in effect for making sure that the transactions are processed within a reasonable time frame or a predefined time frame, and being able to report out on that. You start bumping up against the edges of that when your scalability is not there, because you end up continuing to push the deadline on getting those reports out, which then is yet another indication that the legacy architecture is not satisfactory for the existing environment. And then what we're seeing more and more is the integration with third-party applications. And so if you think about how people are actually dealing with financial transactions today as opposed to the way they did it in the past, there's a dramatic difference in the way that people work. And because there's a dramatic difference in the way that people work, there needs to be dramatic improvements in the way that these different types of systems all interoperate. So there are growing challenges that require acute attention to modernizing the legacy transaction processing systems. Let me give an example. This is the digital savvy millennials who this is how they communicate. They may be standing in a row. They're all talking to each other, of course. They're doing that through their phones. And so the gentleman on the left says, "Who wants to see that concert tonight?" Of course, through a text, and everybody responds. They say they all want to do it. So the next thing that this person does is he goes to the online system to purchase tickets. That system is set up to either integrate with the credit card processing or with the debit card processing, or to directly debit out of a financial institution account. That person buys the tickets, then communicates to the rest of the team, "You need to pay me back." Now, in the past, somebody would say, "You need to give me money," and they would open up a wallet and pull cash out. Well, the millennials rarely use that. They actually will just use their apps to Venmo, maybe small amounts, even smaller amounts than this. I got a Venmo the other day from my daughter, who Venmoed me $2 to pay me back for her using a credit card to buy a candy bar for a friend of hers who was sad. Literally, we're not talking about huge transactions that are being done through these networks. We're talking about microtransactions. When you start looking at the range of different places where microtransactions are taking place, fully across the board when it comes to apps, when you look at games, when you look at any type of store or retail systems or applications that are sitting on people's phones, these are all need to be fully integrated with financial institutions to be able to facilitate execution of these different expectations, interaction patterns with the different financial services providers. So it's multiple layers when it comes to being able to facilitate these much more scaled up degree and volume of financial transactions from the consumer level. So one of the ways to think about this is that instead of relying on a traditional mainframe on-prem architectures, to start thinking about different types of architectures that are able to support large volumes of massive amounts of simultaneous transactions that need to be validated and ensured that they execute in the right order, et cetera. And so a lot of organizations started to look at this concept of an in-memory database architecture. And in-memory architecture is robust to be able to support the transaction processing, and under the right circumstances can automatically scale to be able to support increased volumes or to scale back in elasticity when you've got reduced volume. So it can support the degree and the volume and the performance of execution in sub-second response time, which is a clear expectation. At the same time, it gives you the ability to have accessibility to the data that is being loaded into that in-memory database and be able to support analytical processing. And the value proposition for that is that at the same time that you want to be able to support the transaction processing, there are analytical models and analytical decisioning modules that need to be executed or integrated fully into the information production streams to identify transactions that might not be executed properly, to look for potentially fraudulent transactions and do inline fraud detection and prevention, to be able to do reporting, immediate reporting, so that if there are issues that require some additional activities in the back that need to be done, those can be addressed. If there's any type of compliance, for example, if there's a transaction that implies potential money laundering, that needs to be identified in real time, et cetera. And so the benefit of having an in-memory database architecture is that you got access to the data for transaction processing, and the same data is immediately available for analytical processing. And in fact, what this leverages the ability to have interoperable components for managing the data in memory and allowing computation that is either transaction processing or analytical processing to touch the same data. Now, there's some degree of sophistication that's necessary in order to ensure the transaction semantics, et cetera, and that is a level of detail that hopefully we can drill into a little bit later, perhaps in Ash's talk or in the Q&A. But the benefit of this architecture, and here if you see the image on this slide, is that I've actually kind of adapted it, which is that you could have an in-memory architecture and still install that within your traditional data center. But the benefit of this approach is that these components can be launched and managed within cloud service provider environments on the platform. So this in-memory architecture is actually nicely suited to cloud deployment. And in fact, you benefit from the cloud deployment because instead of relying on a particular, if I go back to this other picture, relying on a particular configuration of these different components, I can actually rescale automatically, or I can have on-demand elasticity if my increased degree of demand for simultaneous transactions at a particular times of the day increases, I could scale up my transaction processing computational resources. If I have more complex analytical needs or integrated analytical models that need to be used to monitor for particular types of actionable triggers, I can scale that up as well. But if I have a reduced period of demand, I can actually scale that back and have reduced use of componentry. It also allows me to kind of replicate or containerize these different components and be able to deploy them across multiple clouds service provider environments. So I can have an engineered network of these implementations that I can launch depending on what the particular need is and where I want to be able to deploy it. It can be done across a multi-cloud environment. In fact, you can do it across a hybrid multi-cloud environment and be able to leverage both on-premises systems and cloud-based systems as well. So we get this multi-platform integration that gives you some definite scalability benefits. Now, you don't want to just go with any kind of in-memory databases, and in fact, there is a risk somewhat if you just go out to the Apache website and pull out whatever the latest version is of some implementation. You really want to look for a provider of an in-memory database that's been enterprise-hardened and that it can support not just the frequently accessed data entities and real-time sub-second response time for performance, but also be horizontally scalable so that it can take advantage of cloud resources and be able to be deployed across multiple clouds, but at the same time have the level of business continuity and enforcement of semantics and the backups and recovery and fault tolerance that you were expecting in any kind of transaction processing system. And this is not something that you're going to just rely on a component that has been crowdsourced into an open source environment. You really want to look for those core capabilities that allow you to get the benefits. Now, how does this benefit an organization that is looking at modernization? And I think the real question here is if you look at where we're going, financial services back office systems are, as I said, they're typically on premises, they're in data centers and they're mainframes, and you can have increased amount of real-time streaming interactions that are being supported by handheld or smartphone or smart application apps, but the inclination might be to say, well, let's upgrade our mainframe, or let's modernize our mainframe and try to get it to support this geometric increase in volume of connectivity and volume of transactions. But really, what you want to think about this is that maybe that mainframe is not the right platform, and maybe you really want to start looking at transitioning to a different type of underlying architecture. The problem is that you don't want to do that and flip a switch and then find out that you've implemented some kind of technology, but you are not really prepared to have that be completely supported. So you want to be able to have a transition period, and this is where we talk about the legacy renovation using this data layer. What we really want to be able to do is implement some kind of microservices layer that intervenes or acts as a proxy between your underlying back-end systems and your front-end customer-facing applications. So it gives you the ability to put that intermediate layer that allows you to replace the underlying architecture ultimately with this cloud-based collection of in-memory databases that then has a minimal amount of disruption, because what you've really done is you've inserted that proxy layer between the consumers and the underlying back-end system, and it gives you the opportunity to build and test that back-end, that modernized back-end, without necessarily switching over to it until you feel comfortable that it actually is working the way it's supposed to work. So if you do this, the modernized environment will then be positioned to not just support your own organization's apps and their types of transactions, but in fact, when you develop this microservices layer and APIs, you can encapsulate the different types of services you want to expose to your trading partners or your business partners, to allow them to integrate third-party apps and their own stream processing into your environment. So what this does is it doesn't just allow you to migrate your own organization's customer-facing applications, but then allows you to integrate with other payment processors or other financial institutions, or to be able to enable multi-threaded transaction streams that cross multiple organizations. to allow there to be a lot greater flexibility. But all this is essentially transparent when you look at your audience, and they're all just kind of sitting and staring at their smartphone apps. They no longer have this challenge of having to figure out how to get something out of one app and moving it to some interim location, then be able to move it some other way around, but allows your partners to leverage those APIs, and by doing so, it will also increase the volume of transactions, and therefore ultimately increase visibility of the services that your organization provides. Now, again, we can focus on this whole concept of transaction processing and straight-through processing, those types of things. But it is valuable to talk about the analytics side, and in-memory architectures allow for real-time analytics on data that is completely up to date, and it allows you to do use cases like improving the customer experience, especially when you're starting to interoperate with a bunch of other third-party partners, et cetera. It allows you to identify opportunities for selling additional services, for streamlining the way that the interfaces that the customers deal with. It does allow you to do real-time fraud detection and ultimately real-time fraud prevention. They're starting to see a lot of organizations that are able to do this, where they identify transactions in real time that are deemed to be suspicious. It becomes more difficult to do that if you are transiting multiple layers of opaqueness, because you've got different types of third-party applications that are layering on top of that network. But what you can start to look at doing is understanding how those network capabilities are streaming data into your in-memory environment, and be able to develop even smarter models that can identify questionable transactions. It also provides real-time personalization, so that it's not just providing the ability to predict whether a customer might be interested in an upsell to a particular new service, but even being able to say, hey, I noticed that you do these types of transactions. Maybe we can simplify the way that those transactions are being done, or maybe we could help you set up an automated mechanism to pay your mortgage every month instead of having you log in every month on an irregular basis. Or maybe we can integrate some kind of other additional account categorizations and classifications that would simplify the ability to automate a lot of those transactions, et cetera. And then this concept of always-on banking. I mean, it used to be that a bank was open from 9 o'clock in the morning till 3 o'clock in the afternoon. Now I can access my accounts at any time of the day and do transactions any time of the day. They may not always execute when I expect them to, but some of them actually do. If I perhaps wanted to transfer money between one account and another account, and it's Sunday night at 11 p.m., even though the bank is actually closed, the transaction may actually go through, and it will be reflected in the account management that will demonstrate that the transfer has actually taken place. Well, that's something that didn't happen in the past. You couldn't do that when all you did was batch processing that was being done based on a paper trail coming out of the bank. So all this, all these capabilities, and these are just simple use cases. I'm sure we'll chat about some other ones. This is all within the context of a robust and secure application layer that is supporting those capabilities. But here's some of the key issues here. We want to have modernization without disruption. And that means having an enterprise-grade system, consumer-grade experience, all together. We want to be able to reduce the risk and modernize without disruption. We don't want to lose enterprise readiness to be able to add on new services or new capabilities in an agile manner without having to take systems down and take them offline, and essentially give banks access to the leveraging cloud economics and the support of elasticity and burst capabilities, all within a hybrid deployment model. I apologize for the misspelling there, but allows you to do hybrid between on-premises and cloud-based environments. So literally being able to get this capability to modernize a legacy system to be able to use the scaffolding of microservices layers to enable that, and then transition out of a single on-premises monolith into a more agile environment that takes advantage of cloud-based economics and cloud-based services. So to summarize here, enterprise-hardened in-memory databases support transaction architectures for real-time transaction processing. In-memory databases provide a streamlined pathway for what is referred to as digital transformation. So if you're going to consider this type of approach, look for a hardened cloud-based platformware that supports high availability and automated failover. So that's enterprise hardened. That supports a hybrid multi-cloud environment, provides horizontal scalability to provide dynamic performance demands, and then fully integrated security and protections. And with that, I am going to thank the audience, thank TDWI, and thanks the folks from Redis for sponsoring the event today. I'm going to hand it back to Brenda.
Great. Thank you very much, David, for that information. So just a quick reminder to our audience, if you have any questions at all during today's program, enter them in the Ask a Question window. We'll be answering the audience questions in the final portion of our program. And now I am pleased to introduce our next speaker, Ash Sahu with Redis. Ash is Director of Product and Solution Marketing at Redis. He has broad experience with launching in-memory databases, big data, analytics, and AI products at companies like SAP, Cask Data, and Google Cloud. Welcome, Ash.
Well, thanks so much, Brenda, and thank you, David, for a really insightful presentation about financial services, what's going on in that modernization journey. Let me start this presentation by asking you all a question. And the question is, what are your current data challenges that are slowing down modernization? Slow applications, data silos, monolithic applications. You lack the skills and technology to keep pace with this rapid changing marketplace. And if it's something else, just feel free to add it in the Q&A chat where you can type it in. We'll take 30 seconds. Pick one or more if it matches what your on-ground reality is. Whether you're in financial services or the ecosystem, doesn't matter. I'd love to hear your experiences on what's going on. I'll wait for a few more seconds.
No, Ash, I'd be surprised if everybody didn't click on all of these.
Yeah, no, I think it was a loaded question. So let's actually look at the answers. And I understand a lot of people will be watching this in a recorded mode, so we might not get as many entries. But let's look at what their answers are. Slow application, data silos, monolithic applications. I'm wondering if we got anything in Q&A chat. If not, so I'm seeing a large number of answers for data silos, right? And then a large number of answers for lack of skills and technology keep pace. So that's good. Let's keep this at the back of our mind. And I'm actually going through the presentation and show you what a survey from some analysts actually showed us. So let me start by this presentation by just really introducing the topic. David talked about how do you modernize without disruption. And I'm going to talk about how do you meet the real-time requirements of real-time banking. So my name is Ash, and I'm the Director of Product and Solution Marketing at Redis. One of the big part of this presentation is to really talk about the importance of having the right platform to drive your digital transformation. Now, as we know, data is the new oil, and databases is the engine for the oil. So picking the right database will give you not just to meet the current needs, but also future-proof the upcoming needs in the future. Let's go back and just summarize what David talked about in terms of what's happening in financial services institutions. To be honest, it's happening across every single every single sector and vertical we're looking at. But financial services institutions are facing a race for digital transformation. There are three big forces pushing hard on them. First is declining top-line growth. So firms are experiencing low growth because of ultra-low interest rates and new regulations. There's a changing consumer and client expectations. David just mentioned about people are no longer going to bank. They go to bank maybe average 3 times a year. They're going to their mobile bank app 300 times a year. And they are demanding responsive, always-on, omnichannel experiences. And finally, what we are seeing is this explosion of digital disruptors, the online-only banks, neobanks, and fintech apps. So established firms have to forced to dramatically improve their customer experience, move towards back office, or risk falling behind. Unfortunately, the very systems which have been powering them and keeping them on those transaction processing systems, we call legacy systems, they're pretty bulletproof. They are the mainframe systems. Usually mainframe systems are actually unable to provide and help to keep up with the digital transformation. They're slow, fragmented, complex, and really not efficient to keep up with a rapidly changing marketplace. Now let's look at something we saw from external surveys, both from a MuleSoft survey last year and Forrester Research survey, which happened a couple of years back. And just like you had responded, a large number of financial services executives believe that their data is siloed. It's slowing business growth, 59%. And the majority of those LOB execs are asking for access to data and information. And 63% believe skills and technology keep pace with digital projects. So it's definitely something which is in line with your answers as well. Data silos, and they lack the skills and technology. So modern FinServ needs a modern data platform. Now let's talk a little bit about, what is really happening. Now, we know a majority of financial service institutions have actually embarked on digital transformation journeys. However, what we're hearing from the field is that that rush to deliver digital services have reached to, their focus was basically on a glossy front end, and they've fallen short on back-end transformation to support these consumer-grade interactive experiences. These back-end experiences like account creation, credit approval, e-commerce, payments, all these things have to be digitized as well for someone to have very immersive interactive experience. And while mobile apps can be, look fast and be slick, you still have the back-end system which has to be digitized. And for that, you need a data system which is not just holistic, but can provide modernization non-disruptively, like David mentioned. We think there are 4 main pillars to a modern data platform. The first one is taken for granted, but people have a strong negative response to slow applications. So sub-millisecond responses. So we talk about our data platform, which is Redis, but any data platform in general needs to be providing sub-millisecond responses for a much more interactive, delightful experience. You need to provide freedom and flexibility to build modern applications. Like David mentioned, it needs to be enterprise-hardened. And finally, run across different deployment options, not just in the cloud, but also in your private data center or in a hybrid model. Let's talk a little bit into each of these sections. So the first thing is, while you've said, and I know there has not been a large number of people who believe that slow slow apps is a problem, but at the same time, realize that a lot of our experiences have been governed and dictated by our experiences with Google's and Facebook's world. So customers and consumers are demanding responsive website experiences, responsive omnichannel experiences. And all of these have to happen even during traffic spikes. So at the base, at the core of a modern data platform, you need to provide speed. And speed not just for read, but also for writes. Redis Enterprise is one of a preeminent platform which allows and supports sub-millisecond responses and millions of IOPS per second under traffic spike, thanks to its in-memory architecture. Now, it's not just for time-sensitive applications services like identity verification, transaction scoring, and fraud detection, but also for, like you said, non-real time consumer experiences. No one likes a spinning wheel, as you understand. Let's talk a little bit about the freedom and flexibility to develop modern applications and talk about the problem, right? So a lot of the digital transformation efforts have been piecemeal efforts. And this has really increased. Well, we went from manual processes, like David mentioned, to piecemeal digital solutions, which have increased fragmentation in data silos. In fact, the problem has become a little bit worse than it was before. And so you need a platform. And Redis Enterprise is one of the platforms which is a general purpose database, which means that it's able to support multiple data types and data models like JSON, search, time series, etc. So you can build one truly integrated end-to-end solution, right? Well, an example is an omni-channel. Customer can start on a mobile app, go to a chat, and then walk into a bank. The data is really fragmented into 3 different data silos. You need a platform which can give you one integrated view of data, and that's why Redis Enterprise really does well, is that it is operationally simple because it's one platform, but it's allowing multiple purpose-built data and technologies to be powered by it. It's more important when you think of architecting and trying to decouple a monolithic architecture with granular microservices. This is where we do well. You can surround a legacy infrastructure, monolithic application and decouple it with microservices. This will allow access to data and customer information. A regulation like PSD2 in Europe, which is about open API banking, really helps to, is one of the things that's driving adoption of in-memory data layer. Enterprise-hardened for mission-critical systems, it's financial service institution, time is money. Downtime means it's a latency, downtime is an outage, and it costs banks and institutions money. Redis Enterprise is battle-tested for enterprise readiness, 5 nines SLA, active-active geo-distribution, single-digit seconds failover time, multi-layer security provisioning, SOC 2 compliance. All of these things will give your DevOps team a peace of mind. And to support for things like online and always-on banking. Flexible deployment options. I know there were some questions in the audience. So not only from your private data center, but public as a managed service across all the hyperscalers like Azure and Microsoft, Azure, AWS, and Google Cloud. The service is available. It's containerized with support for Kubernetes, so either PKS or Anthos. Redis Enterprise can be used in a containerized Kubernetes environment. Just to give you that flexibility which is required in banking institutions. Let's talk a second about, now you can use Redis Enterprise across a lot of applications, your mobile banking apps, etc. But the big ones we want to talk about are real-time fraud detection. David mentioned that it's important to prevent fraud while it's happening, before it happens rather than after the fact. Always-on banking is all about not just speed of response, but also uptime. Omnichannel personalization is all about giving one integrated view of data across, avoiding the data silo problems you guys, all of you responded to. Open banking is API access and giving you a way to pull monolithic applications. Redis Enterprise can be employed as a way to create microservices as a serving layer, but also a speed layer, because these applications need to be responsive. I have a reference diagram which we will keep in the PDF you can show, but I don't think we have enough time to go over it in detail. I just wanted to give you a little bit of a sense of how Redis Enterprise can be used in a typical fraud detection platform. And we have some customers, reference architects, which are using it in a similar way. On the left-hand side, you will see that there is the transactions going on, and then you have ways that the customer shows their identity, whether it's password or it's biometric information. This is recorded, this digital transaction is recorded by our Event Hub, which uses Redis Streams. It's a streaming pub subsystem which asynchronously sends information to update the latest information. So one of the things is about digital identity is that, it has to be fresh. That most of the hacking happens because the digital identity has gone stale and someone has taken over it. You're not able to refresh it, either in the backend systems or the front-end systems. This allows you to really asynchronously update digital identity, not just authenticate, but also update the digital identity. And then you can validate using a search and analytics tool like Redis Search, which is part of Redis Enterprise platform. You can apply probabilistic filters like Bloom filters to make sure that the identity falls into your, its authentication per se. And then transaction storing, we have Redis AI, which will allow you to run smart pattern matching to understand if there are problems and is it a potential fraud or not, and flag them. All this is also recorded in the Redis time series, which is the time series database, to allow you to see patterns over time, so you can understand and audit information post. This system, as you can see, is using Redis Enterprise to do three things: real-time transaction scoring, digital identity validation, and also analytics using the time series data. With that, I'm going to actually just talk 1 second that Redis and Redis Enterprise are used widely among financial institutions. In fact, 4 out of the 5 banks in the US and worldwide use Redis, and the Redis Enterprise is also widely adopted as an enterprise version of Redis. A quote from one of our financial services reference customer, Deutsche Börse Group, talked about Redis Enterprise supporting throughput and latency requirements. Deutsche Börse is required to guarantee to its regulator and customers. As you can understand, customers is only one of the stakeholders for a financial service institution. Regulators are also keen to get information, timely information, and also be notified if there are some kind of red flags, especially with scenarios like AML, like anti-money laundering regulations, KYC, know your customer, etc. So we play a very big part in ensuring that compliance against regulations as well. With that, I'd like to just end my part of the presentation. Well, thank you so much. I hand it back to Brenda to take over the next part. Thanks so much.
Great, and thank you so much, Ash. And yes, we're now going to go ahead and move into our audience Q&A. So we've got a few minutes here to get through some questions. So if you have any questions you haven't entered yet, go ahead and do so now, and we will try to get to that. I'm going to go ahead and start with this one for David. Someone is asking, we are not a bank, but we manage financial transaction processing for our insurance claims, or for insurance claims. How could we leverage in-memory data management to improve the way we provide our services?
So that's a really good question, and it's actually one that I'd been considering in conversations with a relatively large insurance organization recently, because one of the things they were looking at was specifically what's being asked here, which is they outsourced some large component of their transaction processing coming in from the individuals who were submitting the claims. That was being bunched up geographically by individual other organizations, excuse me, who were then pushing batches on a daily basis back to the organization. The organization looked at that and said, is it possible that we can do this more efficiently and reduce reliance on these third parties to be doing bundling of our customers' transactions, or the submission of these claims, but also by using a straight-through processing mechanism, they could actually provide payments faster to those submitting the claims. And so what they wanted to do was look at other architectures for supporting that capability, but they also need to manage the risks by having fully integrated fraud detection in real time. And so an in-memory data management platform or an in-memory database that's coupled with integrated streaming and integrated other types of componentry. Ash mentioned Bloom filters. I mean, that specifically actually might be a really good component to add into that capability to validate the submitters of those claims, and doing it in a way that is efficient and fast. I mean, these are the types of architectural decisions that an organization would need to make to be able to support transitioning from from a batch-oriented that's facilitated by third parties to directly integrating a consumer-facing application with the individuals who are your primary consumers or primary customers or primary claimants. So certainly an in-memory data management system provides you with the ability to push the data in there right away and be able to process those transactions, and yet still have the ability to do the types of fraud analyses that are necessary to prevent claims fraud. And Ash, I don't know if you had any thoughts on that.
No, I think that's good, David. Thank you.
Great. I'm going to go ahead and push this next question for Ash. What do you define as a real-time application? Most of our applications are not real-time. Where can Redis play a part?
Yeah, thanks, Brenda. And that's actually a really good question. I know only a few of you indicated slow applications being a problem with modernization. I'd like to emphasize that, one of the things is we think of real-time as time-sensitive applications. Time-sensitive where time is money or time is risk, right? So if you think of fraud detection, it's a classical use case where, as David mentioned, you need to catch fraud before it happens rather than after the fact. And these applications have to be not just responsive in nature, but they should also be in line with the transactions as it's happening, right? So you could find a fraud, put in your data mart or data warehouse and run analytics at it, and you figure it out in a very, I guess, in a very sure and confident fashion, but it's too late. And that's more like fraud forensics. What we play a part, when I think of time-sensitive real-time applications, is where it's happening at the time the transaction is happening. A lot of these applications, which are real-time or not, near real-time, you think of high-frequency trading, you think of fraud detection, identity verification, digital identity verification, transaction storing. All of these are, I think, time-sensitive applications. But there's also what I think of non-time sensitive, which are non-real-time but important, where response time is important. We talk about consumer and client experiences. It is, as we've gotten used to mobile, applications that give you responses, that latency is the new outage. And in fact, the research has shown, Google did a research a couple of years back, that as you increase latency from 100 milliseconds to 400 milliseconds to a second, you see between a significant 5% to 10% drop in users. And those users are never coming back. Those users are lost forever. So what Redis Enterprise and Redis considers, I guess, real time is less than 100 millisecond response times, round trip from client to server to back. This includes the processing time, of course. Most of our responses, when we think of caching scenarios, are less than a millisecond, what I call sub-millisecond. And I think of a traffic spike, and I think of retail, just give you a counterexample where, you're shopping, it's Black Friday. You should be able to provide, your website should be able to provide sub-millisecond or instant responses, even under traffic spikes. And that's what Redis Enterprise has been battle tested to do. So at the end of it, what you're getting for is a platform which at the heart of it keeps in mind the modern application needs. Not just application consumer experiences, but also microservices. Think of those APIs. You cannot have latency on those APIs. They have to be responsive because they are leading up to another ecosystem of services. So hopefully that answers like how Redis Enterprise plays a part, especially on the real-time application side of things. David, if you want to add something, feel
no, I don't think I can add anything to what you just described.
Very good. Thank you, guys. Ash, here's one more. We'll try to fit in another one or two here. How can your data platform help in mainframe modernization?
Yeah, no, great question, right? So the typical thinking, which has been in the past, was that mainframe modernization was thought of as a rip and replace, but that has proved to be untenable in a sense that is not something which institutions are going to undergo right away. that modernization is a journey. It's piecemeal, tends to be a small piecemeal journey, move off the hotspots. And our view of modernization is what David talked about, which is modernization without disruption. The mainframe system, legacy systems have been working well for years. And we work with the IT departments of financial service institutions to expand and extend their